Now, this is quite a story from NASA because for the second time in history, a human-made object has left our solar system. NASA has confirmed that the Voyager 2 probe is now in interstellar space after exiting the sun's protective bubble, known as the heliosphere. For decades, Voyager 2 has carried the hopes and curiosity of humanity farther than any spacecraft, save its twin, Voyager 1. Launched in 1977, it has silently sailed beyond the edge of our solar system, transmitting faint but invaluable signals back to Earth. In a mission defined by endurance and wonder, each message received from Voyager 2 feels like a whisper from the cosmos, a reminder that even across incomprehensible distances, our technology and ambition can reach the stars. But if a final signal were to come in, the silence that followed would be more than a technical end. It would be a moment heavy with finality, a potential confirmation of what has long been anticipated. Voyager 2 could reach the limits, not just of space, but of our technological grasp. For more updates, consider liking and subscribing to stay informed. If a last transmission were received, it could be weak, fragmented, and unrepeatable. It would not come with a dramatic shutdown or a definitive farewell. Instead, it might arrive like a ghostly echo from billions of miles away, the spacecraft's signal stretched and warped by distance and time. The signal's data could be sparse, marked by irregular bursts of static and fading telemetry, potentially indicating that critical systems were shutting down. The onboard nuclear power source, a radioisotope thermoelectric generator, may degrade to the point where only one or two instruments could still draw enough energy to function intermittently. The once steady rhythm of system updates might give way to erratic, sputtering fragments. Engineers at NASA's Deep Space Network, trained to analyze the most minute anomalies, would recognize what it meant almost instantly. Voyager 2 might have entered the final stage of its operational life. For many, this wouldn't just be a technical event. It would feel like the closing of a grand chapter in human achievement. Voyager 2 has been a constant in the background of human progress for nearly half a century, sending back data about planets, moons, magnetic fields, and cosmic radiation from distances no other human-made object had explored until its twin passed it. It was the first spacecraft to fly past Uranus and Neptune, the only human emissary to those distant worlds. It carries the golden record, a time capsule of humanity's sounds, images, and greetings meant for any intelligent life that might someday encounter it. Its mission isn't just scientific, it is existential. It represents the outward stretch of human imagination. Such a final signal, if it occurred, would confirm the inevitable truth that the spacecraft had reached a place where human influence could no longer follow. Even with state-of-the-art deep space communications, there are hard limits to how far a signal can travel and still be deciphered. The power constraints have been tightening for years, with systems being gradually turned off to preserve core communication functions. Engineers have long anticipated that eventually there might be nothing left to shut down. If a last gasp of transmission were received after many anxious days of silence, it would leave no ambiguity. The systems that keep Voyager 2 alive, alive in the sense that it can tell us where it is and what it sees, could cease to function. It would then drift in the interstellar void, blind and mute, its antennas still aimed at Earth in a final act of faith. There's a psychological weight to potentially losing contact with something so distant and so loyal. Voyager 2 is more than hardware. It is a symbol of our desire to understand what lies beyond and the patience to wait years, even decades, for answers. It has transcended its engineering to become something deeply emotional, a companion on humanity's journey outward. Each time it sends back data, even about the cold emptiness between stars, it reassures us that we are still in touch with the unknown. Its potential silence would be a reminder of how vast and isolating space truly is. The implications of such an event would ripple across the scientific community. A final signal might confirm not only Voyager 2's power failure, but also hint at a degrading orientation system. The spacecraft could no longer maintain stable attitude control, making even accidental transmissions nearly impossible. That change alone would signal the end of its practical utility. For decades, Voyager 2 has helped map the boundary between the heliosphere, the protective bubble of particles and magnetic fields generated by the Sun, and interstellar space. The data it has collected on cosmic rays, plasma waves, and magnetic fields has helped define the contours of our solar system's edge. That stream of data, invaluable for understanding our place in the galaxy, could go dark if such an event occurred. Future missions will carry on the task, but none with the direct legacy and momentum of Voyager 2. Engineers and scientists have long prepared for this eventuality, even while holding on to hope that the spacecraft might continue transmitting for a few more years. There is always the faint possibility that some system could hold out longer, that Voyager 2 would surprise everyone once again. It has, after all, defied expectations before. But physics is unforgiving, and the thermoelectric generators powered by the slow decay of plutonium-238 are not immortal. Their output has been dropping steadily, and power-sharing decisions have become increasingly difficult. Instruments have had to be prioritized. Some shut off completely, just to keep the transmitter alive. If the balance tipped too far, there would be no going back. A final signal would confirm that this tipping point had arrived, likely permanently. Such a silence would also serve as a sobering perspective on our technological limits. Even with the best minds, the most sophisticated instruments, and decades of meticulous engineering, there comes a point when our creations outpace our reach. Voyager 2 is now moving through a part of space that no other instrument can see directly. The Deep Space Network, with its enormous radio antennas, can still search the sky in that direction. But any faint carrier signal, if it exists at all, could become too degraded to interpret. Our ability to maintain connection with something so far away might finally meet its match. And in that reality lies a challenge to future missions: how to design spacecraft that can survive longer, communicate farther, and perhaps even return home. Yet perhaps the most profound implication of Voyager 2's potential final signal is philosophical. Humanity has, for thousands of years, looked up at the stars with questions. The Voyager missions gave us a way to start answering them, not just with telescopes or theories, but by actually going there. They showed us that we could send a part of ourselves into the void and learn from it. The potential end of Voyager 2's voice would be a stark reminder that every mission has limits, but also that limits can be stretched farther than we ever believed possible. For over 48 years, Voyager 2 has redefined what those limits could be. Voyager 2's journey hasn't been one of dramatic visuals or real-time interaction. It has been a slow, deliberate unfolding of knowledge. Its cameras were turned off decades ago to conserve power, but its instruments have kept listening, kept feeling the subtle waves and particles that fill the vacuum of space. If a last signal arrived, it would be as if a final sensory impression had been transmitted. One last breath from a machine built by humans to be resilient, patient, and endlessly curious. That signal wouldn't be loud or clear, but it would carry the weight of an era potentially ending. It would tell us, in its fading pulse, that Voyager 2 had done all it could. This moment would become one of those landmark points in space exploration history, a quiet but significant turning point. In time, Voyager 2 could simply become another object among the stars, drifting past solar systems that may never know it was there. But unlike natural objects, this one carries intention. It was sent with purpose, with knowledge, and with a message. That alone makes its presence in the interstellar void meaningful. Even if no signal ever comes again, Voyager 2 will continue on its trajectory, perhaps for millions of years, a tiny artifact of a civilization that dared to reach beyond its sky. It's easy to romanticize these events, but behind the emotion lies a deep reservoir of scientific value. Every bit of data Voyager 2 sends back, even in its later years, is scrutinized for hidden clues. Scientists analyze telemetry for signs of what systems might fail first, which instruments could give out last, and whether any anomalies suggest a future possibility of resuming even minimal contact. A final signal would be stored and dissected, not just for closure, but because it might still yield insight. There's always the possibility that Voyager 2 will surprise us one last time. Perhaps it could regain orientation long enough to send a single clean pulse. But such hopes are whispers in the face of probability. Still, hope is part of what launched Voyager 2 in the first place. It was never just about data. It was about presence, about saying that humanity is here, thinking, dreaming, exploring. The spacecraft's potential silence would be a confirmation of how far we've come, but also how much further there is to go. It highlights the gap between our curiosity and our capability, a gap that future generations will strive to narrow. Voyager 2's potential last transmission, if it were to occur, would reverberate with monumental force, especially when considered from the vantage point of deep time and cosmic relevance. The spacecraft could become a relic in motion, a persistent testament to a civilization that once sought to reach beyond its planetary cradle. If its voice were to go quiet, the nature of its continued journey would take on a different kind of meaning. Not as an active explorer, but as a drifting ambassador of Earth, carrying with it the frozen echoes of human endeavor, silently threading its way through interstellar space. The absence of an ongoing signal would mark more than the conclusion of communication. It would signify the transition of Voyager 2 from an operational spacecraft to a celestial artifact. This transformation reshapes how we think about exploration. Missions are often measured by their ongoing utility, the experiments they run, the data they send. But once that utility ceases, what remains is their legacy. Voyager 2's final message, if it came, would confirm its graduation from machine to monument. Its continued path through the galaxy would no longer be driven by real-time discoveries, but by the sheer fact of its endurance. And in this way, it becomes part of a deeper story, not only of space science, but of civilization itself. It is difficult to grasp the scale of what Voyager 2 now faces. It is traveling through a region where nothing around it will change for millennia. There are no planets to pass, no suns within reach for thousands of years. The distances between stars are so vast that even at its current velocity of over 15 kilometers per second, it would take more than 40,000 years to come near another star system. In such a context, the potential silence of the spacecraft would become more than a technical fact. It would become an existential metaphor. It would be a speck of human intention surrendered to the void, existing without guidance, without support, without reply. Yet, its continued voyage carries implications that ripple far beyond symbolic significance. Voyager 2 will encounter interstellar material, magnetic fields, and possibly microscopic particles never before touched by anything from Earth. Although it would no longer be able to analyze or report on these interactions, it physically endures those conditions. The degradation of its surface, the impact of radiation, and the slow aging of its materials become an ongoing passive experiment in themselves. Future missions, if they are ever able to recover or rendezvous with Voyager 2, could glean insights from the wear and survival of this long-traveled probe. Its metallic skin may one day serve as a record of the environments it has passed through. The concept of interstellar archaeology, a field barely more than hypothetical at present, suddenly finds in Voyager 2 its first and most precious artifact. If another civilization, distant in time or origin, were ever to find it, they would uncover not just a machine, but a capsule of our species' aspirations and technical fingerprints. The golden record affixed to the spacecraft, containing encoded sounds and images of Earth, may still survive embedded in the spacecraft's hushed frame, and with it, the embedded idea that intelligence once emerged on a blue planet and reached out into the dark with purpose and curiosity. The physical distance of Voyager 2 from Earth is not just geographical. It is temporal. Each year it grows farther, not only in miles, but in generational relevance. When it launched, many of the technologies we now consider foundational, personal computing, digital communications, global positioning, did not exist in any usable form. And yet, Voyager 2 has functioned through the rise and fall of those technologies. It has endured through changing political climates, generations of mission scientists, and shifts in cultural attention. If it were to fall into silence, it would become a temporal bridge, spanning a time when space exploration was raw and daring to a future where such audacity is rare and precious. Its potential end would also redefine the nature of ambition. In Voyager 2, ambition meant launching beyond the known. It meant accepting timelines that extended beyond single careers, even lifetimes. The mission demanded not only innovation, but patience. The potential silence we might receive from the spacecraft would be, paradoxically, the loudest reminder of how rare and difficult such ambition has become. Modern space missions are increasingly driven by economic calculus, commercial incentives, or geopolitical strategies. Voyager 2, in contrast, was driven by wonder. Its journey was not meant to turn a profit or stake a claim. It was meant to see what had never been seen and to endure as long as it could. And even in potential silence, it continues to push boundaries. It is the embodiment of long-term thinking, of crafting something meant to exist far beyond the span of immediate usefulness. It speaks to the idea that exploration is not always about conquest or gain, but about presence, about being there, no matter how long it takes, no matter how faint the connection. Voyager 2 would no longer be part of our active listening, but it would still be part of our presence in the universe. The confirmation of a potential final signal would also reopen one of the most profound discussions in the philosophy of science: the relationship between data and meaning. For decades, Voyager 2 has been a reliable source of measurable, analyzable information. It has sent back readings that could be graphed, compared, and tested. But if those readings were to cease, the mission would enter a new phase, one governed not by data, but by narrative. The story of Voyager 2 would become an inheritance, one that must be preserved and retold, not just by scientists, but by educators, artists, and future thinkers. Its potential silence would demand interpretation rather than analysis. This transition from data to meaning requires a shift in how we value exploration. When Voyager 2 could still send back data, its worth was in its utility. If its worth were to shift to its example, it would challenge future generations to ask how we design missions meant to last not just through technical lifetimes, but cultural epochs. What does it mean to build something meant to be found rather than simply used? How do we prepare humanity, not just a team of engineers, to live in a universe where our messengers outlast our attention? A potential final signal would also cast light on the fragility of our listening capabilities. For all the investment in telescopes, satellites, and missions, the infrastructure that maintains contact with distant probes is limited and aging. The Deep Space Network, a trio of antenna arrays across the world, is under pressure from growing demand and tight budgets. Maintaining contact with aging probes like Voyager 2 requires not only expertise, but political and financial will. Its potential loss would highlight the delicate thread that connects Earth to its farthest explorers. Losing the ability to hear them, even briefly, is a sobering reminder that our technological reach is never guaranteed. From a broader scientific standpoint, Voyager 2's last confirmed message, if it occurred, would serve as a benchmark in the mapping of interstellar conditions. The precise conditions under which a signal might fail, the drop in energy, the possible failure in orientation, would be used to extrapolate models for spacecraft endurance. Scientists are already looking to apply those lessons to future interstellar probes, such as concepts like the Interstellar Probe mission, currently under study by NASA. These next-generation probes will aim to travel farther and last longer than Voyager ever could, but they will do so standing on the shoulders of Voyager 2's decades of service. The event would also refocus attention on long-term knowledge preservation. The technology used to interpret Voyager 2's signals is becoming obsolete. Maintaining the capability to decode its language, its frequencies, protocols, data formats, requires ongoing documentation and cross-generational training. Without such efforts, future contact, even if technically possible, would become practically meaningless. Voyager 2's potential final signal would mark not only a technical endpoint, but a challenge to our civilization's continuity. Are we prepared to keep our scientific legacy alive across centuries? Or will we one day look back and find ourselves unable to understand the very systems we created? While Voyager 2 continues to travel, potentially silently, it remains part of an expanding interstellar network of human-made objects. Along with its twin, Voyager 1, as well as the earlier Pioneer probes and the New Horizons spacecraft, Voyager 2 joins a growing family of emissaries headed toward the stars. None are yet capable of interstellar communication after power loss, but all represent attempts to cast our presence outward. Each one faces the same potential fate: silence. Yet each also carves a path of possibility, opening conceptual doors for what it might mean to leave a trace in the cosmos. The reality that Voyager 2 might serve only as a trace leads to considerations of scale, both temporal and spatial, that dwarf nearly all other human efforts. Voyager 2 will not fall apart quickly. Space is cold, dry, and still. The spacecraft could remain intact for millions, even billions of years. Long after the languages of Earth have changed, long after continents shift or cities crumble, Voyager 2 will drift onward. Its endurance becomes a mirror to human impermanence. It forces us to think in terms of geological time, galactic drift, and civilizational memory. The end of communication is not the end of existence. This raises an uncanny and sobering idea. What if Voyager 2 outlasts humanity itself? Long after Earth may be rendered uninhabitable, whether by cosmic impact, environmental collapse, or solar evolution, Voyager 2 may still sail onward. In that case, it becomes not just a messenger, but a memorial, a silent eulogy to a species that once dared to dream big enough to build something that could escape its own mortality. A final signal in this context would be a kind of cosmic obituary, not for a spacecraft, but for a chapter of Earth's story. That is why the tone surrounding a potential last signal would not be merely one of loss, but of solemn awe. It is rare for technology to command such reverence. Yet, Voyager 2 transcends its category. It is not merely a probe. It is a time capsule, a scout, a symbol. The fact that its mission has continued so long is a marvel. The fact that it might conclude would be a moment for reflection, not only on the spacecraft's journey, but on our own. The potential silence, too, prompts a reevaluation of how we listen. Much of Voyager 2's significance derives not from its transmission, but from our willingness to receive it. Listening, in this sense, is a cultural achievement. It requires not just antennas and algorithms, but commitment, patience, and a sense of cosmic empathy. If there were nothing left to hear, the burden of meaning would shift back to us. We must interpret, remember, and honor. We must decide how its story is told and what we do with the inspiration it leaves behind. With Voyager 2 potentially silently continuing its journey through the vast interstellar medium, a subtle but powerful transformation would take place, not just in the spacecraft's condition, but in how we must recalibrate our understanding of deep space exploration. The potential end of communication wouldn't simply mark the conclusion of a mission. It would force a deeper reevaluation of what it means to explore when the explorer itself becomes unreachable. What remains is no longer a tool of observation, but an enduring narrative, one that demands to be preserved, expanded, and understood in ever more complex ways. A final signal would represent the moment at which control was irreversibly lost. For decades, Voyager 2 has operated in an intricate dance of instruction and feedback. Commands were transmitted across billions of kilometers, and in return came data, vital, fascinating, irreplaceable. If this feedback loop broke, even partially, the human hand could no longer guide its distant emissary. From a systems engineering standpoint, this would underscore a turning point in the feedback-dependent model that governs all robotic space missions. Without a return channel, any spacecraft is no longer an extension of us, but a drifting legacy. This potential breakdown in communication would call attention to the foundational vulnerability of space missions. No matter how advanced the technology, the single most important thread is communication. Without it, the mission's utility evaporates, no matter how perfectly engineered the hardware. Beyond this technical reality is the symbolic weight carried by the rupture of a signal. Communication has always been central to our species' development, from cave paintings to digital networks to signals cast across space. Losing that link with Voyager 2 wouldn't just be the loss of data. It would be the loss of a voice. The probe would become a mute envoy, representing human civilization without being able to report on its path or progress. In this state, it would cease to be part of the active scientific method and become a kind of cosmic monolith, drifting on a trajectory that no longer informs, only represents. An object cast into interstellar space, containing fixed memories and frozen artifacts, harkens to a concept deeply embedded in cultural mythology, the idea of the eternal witness. Voyager 2, like a stone tablet floating through time and space, would bear witness to epochs that no human eye will ever see. It may pass near gravitational anomalies, encounter bursts of cosmic radiation, or trace paths through gaseous clouds ejected by ancient supernovae. It cannot record or transmit those experiences, but it experiences them nonetheless as an object of human origin. In this sense, the spacecraft's continued journey becomes an invisible line stretching out from humanity's earliest spacefaring dreams to an undefined future. The potential silence would also shift attention to the ephemerality of human engagement in a cosmos governed by extremes. Spacecraft, like Voyager 2, depend on power, and power is finite. When we speak of mission duration, we often overlook that it's determined not by technical integrity alone, but by the fundamental limits of physics. The slow decay of radioactive material powering the spacecraft was always a countdown hidden beneath every data packet. The knowledge that something as basic and unstoppable as radioactive decay could determine the longevity of such a profound mission reminds us of the hard constraints under which all exploration occurs. It is not cosmic hazards or interstellar collisions that might silence Voyager 2, but entropy, the quiet, relentless diminishment of energy. That entropy, though cold and unyielding, gives context to the extraordinary efficiency of Voyager 2's mission. Launched during an era when computing power was measured in kilobytes and programming was laboriously fed through punch cards, it has managed to perform flawlessly through 4 planetary encounters, across multiple software and hardware adaptations, and well into an uncharted realm of interstellar space. In contemporary terms, its memory capacity is minimal. Yet, it has accomplished more with that limited capacity than most modern devices do with thousands of times the resources. Its potential silence would then speak not just to the end of power, but to the masterful design that allowed it to function for nearly 5 decades. That very silence would become an exclamation mark on its ingenuity. A unique implication of Voyager 2's potential final transmission is its reinforcement of the timeline disparity between human lifespans and interstellar phenomena. Most scientific missions are designed around years, maybe decades. But Voyager 2 has lived longer than many of the people who helped build it. Some of its original engineers have passed away. Entire generations have been born and matured during its voyage. If it could no longer speak, we would be left with the understanding that time frames in space don't conform to human expectations. If Voyager 2 were to pass near another planetary system, it might take tens of thousands of years, longer than all of recorded human history combined. The disconnect between our